A VFD and a soft starter exist to do the same thing. Both start a big motor gently, instead of slamming it across the line. Pick the wrong one, and you either waste thousands of dollars, or you burn up the motor and the gearbox over time. So which do you actually need? Quick note before we dig in. This is from PLC Simulator, where you can practice motor control logic-free in your browser. The link is in the description. Now, let us settle it. I will show what each device really does. Then the decision rule that tells you which one fits, and the mistakes that cost people the most. Start with the soft starter because it does one job. It ramps the voltage up at start. When you press start, it does not hand the motor full voltage instantly. Instead, it climbs from a low voltage to full line voltage over a few seconds. That gentle climb limits the inrush current and the mechanical jolt. A motor started across the line can pull 6 to 8 times its running current. That spike trips breakers and stresses belts and couplings. The soft starter tames that spike. But here is the key limit. Once the motor is up to full speed, the soft starter steps out of the way. It bypasses itself with a contactor and the motor runs straight on the line. So it only shapes the start. After that, you have no control at all. Now, the VFD, the variable frequency drive. It does far more because it controls the frequency of the power, not just the voltage at start. A motor's speed follows the frequency it is fed. 60 Hz gives full speed. 30 Hz gives roughly half. By varying that frequency, the VFD controls the motor's speed across the entire run, not only at startup. So, a VFD gives a smooth start too, but it keeps that control afterward. You can slow the motor down, speed it up, reverse it, and hold precise speed under a changing load. It can also save real energy on pumps and fans, where running slower draws dramatically less power. That is the headline difference. A soft starter only shapes the start. A VFD controls speed the whole time. So here is the decision, and it is simpler than people make it. Ask one question. Do you need to control speed during the run, or only soften the start? Say all you need is a gentle start and stop. The motor then runs at one fixed speed. A soft starter is the right call. Think a conveyor, a big fan, or a pump that only ever runs flat out. It is cheaper, smaller, and there is less to configure. But if you need variable speed, energy savings, precise torque, or frequent starts and stops, you need a VFD. Think a pump matching demand, a fan trimming airflow, or a machine that has to ramp and position. Need speed control, VFD. Only need a soft start, soft starter. Let's put them side by side because the trade-offs matter. On control, the soft starter shapes the start only, while the VFD controls full speed for the whole run. On cost, the soft starter is clearly cheaper for the same motor size. On size, the soft starter is smaller in the panel. A VFD needs more space and more cooling. And on energy, the soft starter saves nothing once running, while a VFD can cut energy hugely on pumps and fans. So the VFD does more, but it asks more of you. Read that table the right way, and the choice almost makes itself. One trade-off bites people more than any other. It lives on the VFD side. Harmonics. A VFD switches power electronically very fast to build that variable frequency. That switching injects electrical harmonics back onto your supply. On a big drive, or several of them, that distortion can trip protection or disturb other equipment. So you may need line reactors or harmonic filters to stay within limits. Extra cost, extra panel space. A soft starter, once it has bypassed itself, is electrically clean and adds none of that. So budget for more than the drive itself. You're buying cooling, space, and power quality fixes too. Two mistakes cost people the most. The first, fitting a VFD where a soft starter would have done the job. The motor only ever runs at one speed, but somebody specs a drive anyway. Now you have paid more, used more panel space, and created a harmonics problem to filter, all for control you never use. The second mistake is the reverse. You fit a soft starter, then later discover you need to vary the speed. A soft starter simply cannot do that. So you rip it out and buy the drive you should have bought first. Both come from skipping that one question. Decide whether you need speed control before you choose the device, not after. So here is the rule of thumb to walk away with. A soft starter shapes the start, then bypasses. It is for start and stop only. A VFD controls speed for the whole run. It is for speed control, energy savings, and torque. Match the device to whether you need control during the run. Get that right, and you stop overpaying, and you stop ripping gear back out. Now, go make it concrete. You can build and test the motor control logic that drives a starter or a drive free in your browser. Click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe for a new video every Tuesday. See you in the next one.